doing today is we're going to talk about shifts of graphs. All right? And so it's not just going to, and primarily is not going to be absolute value at all. However, until we do our homework, which will be shifting absolute value graphs. Okay? So I feel pretty confident from talking to you that you know how to graph the absolute value ones. I'm going to point out a few other things about absolute value before we start, or while we're going through this. Okay? So, taking a look at this sheet. If an equation of a graph has only one x in it, okay, not counting the f of x part, remember f of x is function notation, then you can use these following guidelines for shifts. Okay, this is a good note page to keep in your binder. And like say for 2 years, so when you get to trig, all right, algebra 2, you'll be ready. You'll be like, look, I've saved this for 2 years. Mr. McCoy told me to, and now I'm a big bad junior, and I'm ready to go. Or a big bad sophomore.
Yeah, I'm totally going to do that.
I would. Okay? A vertical shift of the graph is found by identifying the x or the k term of the function. Now first, everyone needs to understand what vertical and horizontal means. So with your arm, show me vertical, please. That's like some of the best. Some of you still don't know what vertical is. Vertical, that's the best. Some of you have raised your hands all year. That's awesome. Okay, horizontal, go to horizontal. Good, horizontal. All right. So if I'm shifting a graph vertically means I'm going up and down. I have to identify the k term in a function. Now, if you think of your function as like a yard, or like your house and a yard. Your house, you have the inside of your house that you clean up, right? Everyone stay with me on the analogy here. House, there's like the inside. You have to clean up your house.
I love cleaning.
And then you have your yard, which is outside your house. Now, how many have to clean your house? How many have to clean the yard? Like mowing, like taking care of the yard. Okay. How many have to do both? I'm just curious. Dude, that's good. Come in, come show me. Oh, forget it. All right. Okay, need your attention back up here. When you're dealing with a function, remember f of x is the same thing as y, so we just kind of ignore it. That's just telling where x is a function, or f is a function of x. Okay. When I move into this over here, this is my house. My house has walls. Everyone see the walls on the house? Now that is not what my house looks like, though it would be a pretty sweet looking house, I gotta say. It'd be easy to identify your house on the block if it looked like that. Okay? X. Mr. Bartlett, we have a student in here actually named X. That's how mathematical he is. Yeah, I know.
What if his middle name was Y?
X, you could make your house like that, dude. Put a big X on it. Be sweet. Okay? All right, we have X. All right, it's not X's house, but this is your house. Is the K in the house or in the yard? In the yard. The K is what's happening outside of the house. K deals with your things that happen on the outside of the house, move graphs up and down. Now, guys, I'm kind of messing around with the house and yard stuff, but if you think of it that way, the stuff that happens on the outside is what's moving your graph up and down. It's affecting you vertically. The stuff that happens on the inside affects you horizontally. Not yet. Okay, so let's go through that again. Stuff that happens on the outside affects it how? Vertically, and stuff that happens on the inside affects it horizontally. Key piece there. Yes?
So outside there's grass and it's growing up?
No, we'll deal with the more analogies here in a minute. I don't want to. Okay, so this one, just like yesterday, whatever we're adding shifts it up, whatever subtracting shifts it down. All right, so on these functions, these are all different types of functions that you're going to study at some point. Most of them have different pictures to them. Obviously, well, we'll let you figure that out here in a minute. I want you to tell how these are shifting based upon what you see there.
What do you mean
how they're shifting? Up, down, left, right, how far? This thing right here is called a pencil. And if you write with these, now I know from following me and the way I do lessons, I use pen so often. you wouldn't even know that a pencil might exist. However, it's a pencil, and there's something magic here. Like if I said, for instance, this shifts up 3 units. Oh, I spelt up wrong. Well, watch the magic. I know. So those of you afraid of writing an answer, if you use a pencil, you can actually fix that. I know. Jill, what's this one do? Up 4. Sergi, what's this one do? I gave you the tough one, man. Saved it just for you. What's in your yard? Nothing, dude. So what happens? Yeah, it doesn't shift at all. Stays the same. No shift. This would be a +0. That means your yard's clean. Well done, Sergi. Way to keep it cleaned up. What's this one? Up 4. How about this one? Down 2. And here? Up 6. All right. How many think you got it? I know some of you are afraid to write, but using the magical tool, which we call a pencil, you have power. All right.
A very smart person.
Yes, I think. Okay. Now, this has nothing to do with our shifts. I just want to see if you can tell me which functions have the same family. In other words, which ones live in the same house.
Is it the ones with the same yards?
Okay, go ahead. Let's call this function 1, 2, 3, 4, 5, 6, 7, 8. Which functions would live in the, well, maybe not the same house. If we have to stick with our analogy, like the same neighborhood. Okay? Hey guys, so that's a good way to think about it. How many neighborhoods are there?
3.
There's 3. You have this neighborhood, which we would call what neighborhood?
The 1, 2 neighborhood.
The 1 over X neighborhood. Are these in the same neighborhood? Yes. Okay. This one is the root 3 neighborhood, or root X neighborhood, excuse me. And is this one in that neighborhood? Yes. Is this one in that neighborhood? You sure?
No.
Yeah, let's vote. How many think this house is in that neighborhood? How many think it is not? Some of you just look around at your neighbors. Isaiah, why is this house not in that neighborhood? Nope. How about this house? Is that house in that neighborhood? No? Help him out. Why not? Logan, what do you think?
I think that I thought that the
X to the second power. You think what? Yeah, X to the second power has its own neighborhood. Right? It's a little more powerful than this out. All right? So, how about this one? Which neighborhood is this one in?
It's in the X squared neighborhood.
X squared. How about this one?
X squared.
X squared. How about this one?
X squared.
Okay? Everyone get how you determine the neighborhood?
You look at the house. It's the house.
Yeah, you look at the house. All right? Now, just so that we're clear, we could talk more about those neighborhoods later, but if you really want to see them, they're actually on those pictures out there on the window.
Yay.
All right. Not exciting neighborhoods. Let's go on to horizontal shifts. Horizontal shifts start with an H. What does house start with?
H.
I know. I wonder if they did that on purpose.
Maybe.
Maybe. Probably not. All right. A horizontal shift of a graph is found by identifying the H term. The H is a positive real number. And notice H, which is what horizontal starts with, is always inside the grouping symbols or inside our house. So I'm hoping you're making notes of this. You're like really getting it here. So the graph of f of x equals x minus h. Now that's just a general format. This says that anytime I take my grouping symbols and I subtract h, I shift my graph to the right h units. Now, we dealt with this yesterday, right? Remember this? We had y equals the absolute value of x minus 4. Where did that shift?
4 right.
Tell your neighbor quickly, where'd that shift?
4 right.
Okay, everyone point in the direction it shifted. Now, don't wait for your neighbor. Like, close your eyes and point. See if you get it right. See if you get it right. Shifts to the right. To the right 4 units. Remember the format. Y equals a times x minus h plus k. Remember the minus, it's always backwards. Like if it's negative 4, it shifts to the right. Thinking of a number line, it's kind of counterintuitive when you're dealing with stuff inside your house. Like here's 0, here's positive, here's negatives. When we're shifting, when it says minus 4, we actually go this way 4 units. When it says plus 4,
We go the other way.
we shift that way 4 units.
That doesn't make this, wouldn't it make
That's the
more
plus
sense?
and that's the minus.
No, because looking at the graph.
Okay,
Yeah, looking at
now
the
if you
graph.
recall yesterday, I told you guys to figure this out a different way. I said, don't really focus on the h. Think of it as, tell your neighbor what I told you to think of this as.
Equation to get it to 0.
Okay, someone from the back of the room. What did we talk about yesterday? Logan? We did. That gave us the positive there. That wasn't the thing that I was thinking of. Okay? Yeah, it's what can make this thing equal 0. That's really where it shifts to. So what makes this thing equal 0 is 4. So it shifts to the, it goes this way, 4. And what makes this 0? Negative 4. So it shifts to negative 4. Okay? You can also just memorize, hey, if it says minus 4 on the inside, it goes to the positive 4. And if it says plus 4, it goes to the negative 4. The key piece there to understand, though, is it's when there's nothing in front of x. We don't see a number. Because if we put a number out there, then it changes things up a little more. You're not going to see a lot of that right now, but you eventually will. So right now, looking at these, notice you don't always see grouping symbols. We've got some weird-looking houses here. Well, some of them like them. Good job, Jason. Proud of you. All right? So, looking at these houses, these different houses, I want you to figure out where they're shifting, which direction, up, down, left, right, and how far. Okay? All right. And then you can identify which ones live in the same neighborhood if you want. This one right here, which way is it shifting? Going to right,
Right
2. This one?
Right 3.
This one?
Left 3.
Okay, so here's your house down here. Okay? And we are going to the left 3. Okay, and it's because it's plus. All right, and here we don't have any grouping symbols at all.
Not shifting.
So none. No shift. Just put none. Okay, how about this one? Oh, Isabella, a question?
If you're shifting it like kind of to like minus h, if you're shifting to the right, then isn't it going positive, not negative?
If you're correct. But that's why we say, because vertex form is x minus h. So really you're just focusing in on that piece. You're not, the minus is part of your form. Okay, so it's just whatever's here. So when you get a plus, like on this one here, you have x minus negative 4. That's how you get that positive. So you're actually, that negative 4 is where you're going to. Okay? So on this one, since it's minus, we just focus in on the 2, and we're going to the right 2. This one is to the
Left 3.
left 3.
Right 4.
Okay. So once again, you can kind of see the different neighborhood. This one, does it have anyone else in the neighborhood?
Yeah.
No.
The one.
It's only
It's really blurry.
Yeah, you don't have anything else, any other ones where you have an x in the fraction or in the denominator. Does this one have any others in the neighborhood? No other radicals with x in it. How about this one? Any other cubics?
It has
No.
Nope, these are all squared. So all of these are in a neighborhood by themselves. These have their own neighborhood.
Those are the cool people.
They've got to be nice though.
Wait, that x squared,
Mm-hmm.
wouldn't it be different than the other ones? Because it's not.
No, these are just shifted away from the. This one's like two houses down. This one's 3 houses that way. This one.
Oh.
Oh, yeah. All right.
And the last one's on the other side.
Okay, moving on. Next page. Turn it over. We're going to talk about stretching or compressing.
Just keep adding more.
Remember, compressing, we've also called, this book calls it shrinks. So you can think of it as a shrink.
Opposite of stretching.
Compressing is the opposite of stretching or shrinking there. A graph is obtained. Yeah. By the A term outside of the parentheses. A graph that should read, that is obtained by the A term outside the parentheses. F of x equals A times x minus h plus k. Okay, if there are not parentheses, the A term attached, or is attached to the x. For instance, in this format. So if there aren't parentheses, it's just attached to the x, and when there are parentheses, it has the x minus h. So your A is on the outside of the house. So is it affecting vertical or horizontal?
Horizontal.
It's vertical because it's on the outside. If A is greater than 1, then the graph is stretched. It gets narrower. And if A is less than 1, it's compressed, meaning it gets wider. So if you think back to our homework when we talked about absolute value, when we had that one that flattened out, it's because it was 1/3 versus the one where it was a lot thinner, that had a term of 3. Compared to the parent function, now that's a new term for most of us. Parent function is what it would be when you have a 1 in front. So like the parent function of 4x squared is y equals x squared. What's my a term in x squared?
4.
Nope. What's the a term for this one right here?
1.
It's 1. So compared to that, which we call our parent function, what happens here?
There's 3 more.
Tell your neighbor what happens. Does it get wider, narrower? What
It
happens?
gets narrower. It gets
Narrower and steeper.
Narrower.
All right.
Okay.
How many say wider? Who says narrower? It gets narrower. All right, by a factor of 4.
I knew it got
It's so the way we say it, it stretches by a factor of 4. All right? Why don't you go ahead and tell what happens there? Okay, volunteer. Sarah, what do you got?
For the next one.
Yep.
Shrinks by a factor of 1/3.
Shrinks, or what's another way of saying shrinks?
compresses.
Compresses. By a factor of 1/3. So it gets flatter. This one gets narrower. Longer. Narrower.
Skinny.
All right.
It gets really skinny. It goes on the diet.
Go ahead and finish those up there. Woohoo! All right. What happens here? Stretch or shrink?
It stretches.
Stretch. By factor of 2.
2.
Okay, what happens here?
Compresses.
Shrinks or compresses. All right, and this is
Stretch.
Doesn't stretch or compress.
doesn't stretch or compress. Nothing changes.
Yay!
Okay? All right, so some good questions came up. One of them was, what happens if A is positive? What happens? Well, we know what happens when it's positive. What happens when it's negative? Well, here is in summary what we've talked about. Now, you really have talked about all this stuff. We know what H does. We know what K does. Thank you. Okay, we know what A, H, and K do. Now, if A is negative, what happens is it flips upside down. It reflects it. And it reflects it over the x-axis. Okay? So, for you, what you're thinking, what we're doing right now, just think it flips it upside down. Okay? It takes your graph, what was, like we were dealing with absolute value, it takes a graph that was pointing upward and now makes it point downward.
That's weird.
Okay? That'd actually be a complete reflection. Okay, so the vertex would line up and it'd be, okay, but anyway, I think we get the point. All right? It makes an X, almost. X, all right?
Uh-huh.
All right. So, let's take a look at this and see if we can come up with what's going on here. First of all, you need some background information. We've talked about the different neighborhoods here. The neighborhoods have different looks to them. The neighborhood for just X, which you won't see here, is a linear, it's just a straight line. We've done that one. The neighborhood that is X squared, what's that?
Is it like double? A straight line, but it's still like double.
It's a parabola. It's a U-shaped. That thing right there is the vertex. This thing right here is the thing that you want to move around. So when we say it goes over 3 and up 2, that's the point that you want to move over 3 and up 2. Okay? When it says it gets narrower, you want to make these branches get closer together or wider, further apart. Okay? What's this one look like?
Or it's like a V.
That's a V. That's what we've been talking about, right? How about this one? This one looks like this. It starts at a point, and then it jets off in a direction. It's pretty sweet.
What kind of graph is that?
That's a square root function. Okay, now I'm not putting the f of x equals. So if you want, you could put f of x equals. That truly is the thing. All right. This one right here, x cubed, starts at that same point that we had here. It goes up. It has kind of like half of a parabola, and then rather than going up on the other side, it goes down.
That is odd.
It is odd. 3 is odd. I agree.
Okay.
It's not funny.
All right. Kind of funny.
Let's spin the
All right, so you'll notice on all of these that you see these points on. When we say, for instance, it shifts, so like on this one, how far do you move horizontally?
3 to the right.
You go 3 to the right, and what happens here?
You go up 5.
Down 5, so you go 3 to the right, you go down 5. What's the negative tells us?
Go. That is fun.
It opens down. Okay, and the 2 tells us it's?
By a factor of 2.
Is it a stretch or a shrink? Stretch. Means it gets narrow. Okay, so what we do is this belongs to the x squared neighborhood. X squared neighborhood is right here. That's going to be your picture. So we're going to take this point, so the vertex, we're going to take that point and we're going to move it from the center, 3 to the right, down 5, and from there, we know our picture opens downward, and it is a little narrower than what a normal parabola would look like. So we kind of make it a thin parabola.
Pencil.
Okay, that's all we're doing with that. Now, when we say it opens down, notice if this one opens down, well, you're like, well, it's already opened down. Well, if it's negative, then we just flip it. This part goes up, so it would be, rather than rising left to right, it would be falling from left to right. So the negative, this would be the positive version. The negative version of this one would go like that. Okay. I want you to try to do your best right now to sketch some pictures for those.
I like pictures.
So I added a bunch of things there, and some of you are having a hard time getting started. The first step, just go through and identify these things. Like, what happens? I go to each part, say, okay, what does this tell me? What is that? What is that? What is that? What is that? And then my neighborhood is the 3. Write down what each of those things tell you. Okay? And then once you have each of those pieces, what they tell you, then you put it all together to complete the puzzle. All right. This means it opens down, or reflection. Or in this case, reflect. Okay? This means it's wide. This means it goes to the right one. And this means it goes up to. Okay? So I go this way, 1. I go up 2. It's pretty wide, and since it's a cubic, it does something like that. It belongs to that neighborhood. Got that one? All done? Okay.
How do you stretch or shrink
The square root
yeah.
just becomes narrower, so it goes off to infinity quicker if it's a 2. Yeah. Hey.
In the second graph, wouldn't it have gone like that? Like stretched out wider more? And not thinner?
I tried to get it wider. Maybe I didn't achieve that here. There. I'll try to emphasize the wideness of it.
I'll try to.
Better? All right, a little better. All right. Okay. Hey, what happens here?
It goes
Up 3. What happens here? Stretch. Okay, so we're right there. We don't move horizontally, and it's a stretch. So in a stretch, we go really fast this way. Okay, so rather than kind of gradual, we go really fast to the right. Now, on this case right here, if it was less than 1, it would have to go up faster, or excuse me, slower. It'd be a little wider. Okay.
I like this. You don't have to be exact. You can just kind of.
Yeah, we're just kind of guessing here. What's this one?
For now. True. It's to the left 3.
Left 3. This one?
Down 1.
Down 1. And here? Stretch.
And
Okay?
the absolute value means it's going to go in a B.
Absolute value means it's going in a B. So 1, 2, 3, up 1. It's stretching.
That was down 1. Down 1.
Was it down 1?
Yeah.
Thank you. Down 1. Unbelievable. Okay, and it gets narrower than the normal, which that doesn't look too narrow. Make it a little more narrow. Okay, last one. Nah. This right here. Down 3 here. Right 2 here. shrink or compress, and this, we could flip it, okay? Or opens down, or is a reflection. Okay, and the cubic tells us this. So, we're going over 2, down 3, and it reflects it, and it's really wide. Not quite as wide as our previous one, because it's not. All right. Very good. We got it? Okay, everyone rate themselves 1 to 5. Okay. I want you to, we've done a lot of this right here, but I want you to answer that last question. Suppose the graph of x squared is stretched by a factor of 2 and then shifted up 3 units. What is the equation of that new graph? Yep. All right. Y equals what?
2.
2.
2x. No, in
Parentheses.
parentheses.
I put it in absolute value.
You need to put in.
Nope. 2x squared plus 3. No parentheses. Everything happens outside the house on that. How many got it?
Technically.
All done.
I just copied it down, so I got it.
That's cheating.
No homework.
Cheating. All right. Your assignment. You got your assignment. The amazing fun.
It's okay. We don't have to do an assignment.